Madiha, Rizwan, what did we study last time?
I'm checking. Heating effect of electricity of current, electrical.
Ah, okay. So, Rizwan, Faz, can you open the camera?
So, if I open the camera, the sound doesn't comes.
Okay, that's the problem. No problem. So, what is the syllabus for your coming assessment?
Uh,
Humanize?
it's is light chapter light and human eye and colorful world.
Okay. So, we covered that chapter over here.
Yes, sir.
Okay. So, do you have any doubts? Any question? Before that, you go back, okay, read those chapters and come back with doubts. Okay, right?
Yes, sir.
Okay. So we already calculated the power for the given situation, right? We did some problems, right? How to calculate the power for the voltage, current, and resistance. We all solve these equations, right? Is there this concept clear? The derivations of uh, power, how it related to the voltage and currents, right? This concept, is there any doubt in the calculation of power?
Yes, sir.
So did you try the problems?
Yes.
I given some assignments, right?
Yeah,
You didn't.
so you're lagging, sir. I can't hear.
I said that I provided some assignments on calculation of power. Did you try?
Yes.
You
Yes,
tried.
I have
Okay.
tried.
Okay. Any doubt? Any confusion in anywhere?
Um, yes, sir.
No. What about Madiha? Did you try the assignment?
Yes, sir.
So everything is okay for you. You don't have any doubt.
No, sir.
What about Faz? Did you see the assignment? Did you see the assignment? It seems that he had just logged in and then enjoying the coffee. Your mic is not working. No problem. It's okay. But try to get borrow the headphone from someone. Now it's not possible that in home there is more than 2, 3 headphone or earbud, right? In every home it's possible. At least you will get 3 to 5 headphones or earbuds, something. So it's not the good excuse. You borrow from someone. See, unless until you won't respond, I won't read the chat. Okay. Unless until you won't respond, how I will get? It's not a one-way communication, na? Yeah, you join with another phone, whatever you do. The classroom is that you have to respond. Okay. The meaning classroom is that you have
Sir,
to respond. Yeah, it's audible,
I don't know.
fellas.
Yes, sir. I just
Now it's
continue.
audible. Yeah, it's audible. Okay. So unless until you won't respond, then it's not possible to just making an statements. Your input is more valuable. Your participation is more important than my participation. Okay,
Yes, sir.
just lane. Okay, so calculation of power is now okay. So can we proceed further? So it's good if you will on the camera. Now we are left with one concept. Let me introduce you. First, let's see this. Okay. Let's see this figure. Are you aware of this figure? Uh,
Yes, sir.
yes, so what is the use of these?
Uh, uh, one is voltmeter and another is ammeter.
No,
Is
no,
it?
it's not the voltmeter and a meter.
Okay.
This is the meter which used to calculate how much energy you
Electricity.
have consumed, how much energy you have consumed. Okay, and one of the this is the very classical meter, means that this is the analog meter. Here one thing written kWh. Okay, this is the high-tech meter where you will find number of informations. Here you will find only the numbers over here and one wheel rotating. And this is the kilowatt hour. Kilowatt hour. Kilowatt hour, 1 kilowatt hour is called 1 unit. Okay, 1 unit. Clear?
Yes, sir.
How we'll calculate the 1 kilowatt? How we will calculate the 1 kilowatt? What it will be the equivalent energy? 1 kilo means 1,000 watt. In 1 hour, how many seconds are? In 1 hour, 1 hour is equal to how many seconds? In 1 hour, how many seconds we have?
60.
1 hour.
Jaslyn, that's good. In 1 hour, how many seconds we have?
Something 600
In
or more.
1 hour, we have 60 right? In 1 minute, we 1 minute we have 60
Seconds.
seconds. Okay, so in 1 hour, how many seconds?
600.
So it will be 60 minutes into 60 seconds.
minutes.
It will be like 36.
8,600
Yes,
seconds.
sir.
Yeah, this much seconds, right?
Yes, sir.
So now keep this number in mind. Whenever someone asks in 1 hour how many seconds we have, we will be saying 3600 seconds. So if we will write it, it will be 36. This is second, okay? So this will be 36 into 10 raised to the power 5. 30 from here, 20 from here. So should I increase the size? Okay, this is watt into second. This is equal to watt into second. Okay, so watt into second is nothing but joule. So we may write is 36 into 10 raised to the power 5 joule. Joule is the measure of heat. Nah, heat and energy. Heat energy both have the same form. So it's the form of energy. Clear? So 1 unit equal to 36 into 10 to the power 5 joule. 1 unit of energy, that is kilowatt hour, is equal to 36 into 10 to the power 5 joule, right? This is definition of 1 kilowatt hour. Now we all know in scientific unit, we write numbers in scientific method, in scientific terminology, like something else, in some another matter, manner. Like we have seen that the charge of electron is 1.6 into 10 raised to minus 30, 19 joule, 19 coulomb, not joule. Similarly, if you will write the G is 6.67 into 10 raised to the power something, right? 10 raised to the power 4 or 11. This is 11. So we see that in all these examples, this is charge on electron. There is only one number on the left side, right? 1.67. And the number on the right side may be anything, 2, 3, 4, 5. But the left hand side will be only one digit. So we may write that this number in the scientific terminology. Can we write it? How we will write it? Madhya, how will
Three,
we, how?
so
Yeah.
3.6 into 10 raised to 4,
Yes, 3.6 and 10 raised to the power.
4.
Now I have some calculation, right? What we will do, this is 36,
No, like 6, sir, 6. Not
and now just wait, okay. This is the number. What we will do, we will multiply it and divide it. Clear?
yes, sir.
Okay. So now what we have to do, if we will divide 36 over 10, we will get what? 3.6. Clear? So we means that we have to keep these two numbers together and these two numbers together. So this will be 36 over 10. Now this will be 10 to the power of 5. Here it is 1. So 5 plus 1. So this will become 10 to the power 6. Clear?
Okay, yes, sir.
This is again in the unit of joule. So this is equal to 1 kilowatt hour. Clear?
Yes, sir.
So 1 kilowatt hour is equal to 3.6 into 10 to the power 5 joule. So this is the definition of kilowatt hour. Clear? Got the
Yes, sir.
calculation? So related to this, we are left with one concept. We will do it again and then we will move. So did we discuss this point? Many people think that electrons are consumed in electric circuit. This is wrong. We pay the electricity board or electric company to provide energy to move electrons from electric gadgets like electric bulb, fan. So we pay for the energy that we used. Okay. We don't pay for electricity. We pay for the energy that used to drive the electrons through our gadgets. Clear?
Yes, sir.
So we are left with one concept. Okay, that's related to this question. So that concept is energy supplied to the circuit by source in time t. The earlier definition what we saw in all these definitions, there was no factor of time, no factor of time. But we all know now of time. But we all know how many seconds or how many hours we consume the energy. And according to that, we have to pay the bill. If we use the energy for 1 hour, we have to pay for the 1 hour consumption of energy, right? So we already see the kilowatt per hour, sorry, kilowatt hour. So what does it means? The heading is like energy supplied to the circuit by source energy supplied to the circuit by the source in time t, right? Like that, this is our source or transmission power. The energy is being supplied in this circuit so that there could be the motion of electrons, right? This is the motion of electrons. So we are providing the energy to the circuit. That's make the motion of electrons, and motion of electrons make the electric gadget to work. So we already know that power is P. Now we are applying this power for a time T. So this will be energy supplied. Okay, we may say this is the E. This energy supplied nothing but power into time. We already know power is P is equal to VI. One of the definition is that, right? You remember what is P? Jaslyn, you remember what is P? That is power. What is definition of power? See, if you will keep your camera on, at least I will be having your facial impression. Okay. So I may catch how you are doing. So what is the definition of P phase? What is the P? Here P is power.
Yes, sir. Power. T is time.
Okay. We already find the definition P is equal to VI. And what was the other definition? We already know that we can change. The other was V is equal to IR, then is I square R, right? And then it was I is equal to V over R, then V over V square over R. These were the mathematical expression for power, right? Clear? So we may write it, if we will replace V with V is equal to I time R, then it will be I square R into T. Better I have to write these terms, otherwise you guys will get confused. So I'm not here to confuse you actually. Why this sharp eraser is not working today? So actually, V is equal to I into R, then this is I into T. So this is I square R into T. So where I is steady current, where I is current, R is resistance, R is resistance, T is time. Okay. This is clear.
Yes, sir.
So if this is clear, can you attempt the example number 11.11?
Yes, sir. Yeah.
If you could, then proceed. Jaslin, Madiha, did you get this concept? Rizwan, Faz,
Yes, sir.
then will you then proceed? Madiha, you are not responding to it
Yes,
today.
sir.
Did you get?
No, wait, sir.
Okay.
Done, sir.
Okay. So we will be writing, we have given E, this is 100 joule, and each second, then T is 1 sec, and resistance is 4 ohm. So this will be equal to 100 is equal to, we have to find I square, then R is 4 ohm, then T is 1. So this will be like I square is equal to 100 divided by 24. So how much it will come? 100 divided by 4. Madhya, 100 divided by 4. Jaslin, 100 divided by 4. If you want answer, my screen will go away.
25.
Yep, right, 25. Some power problem. This is 25. Okay. Therefore, I will be how much? How much will be I? 5 ampere. 5 ampere. So what we have to calculate? Find the potential difference. V is equal to IR. So therefore, V is equal to I time R. So I is 5 and R is how much? 4.
Or
So
20
20,
ohm.
21. This is the answer for you guys.
Yes, sir.
And who is in the
Yes.
message box? Who is in the chat box? 25 current is 5 ampere, right? Sir, you are lagging. This is Jaslene. Yeah, there was some network issue. So I think now it's okay. So volt ampere is 5, current is 5 ampere, and voltage is 20 volt. Clear?
Yes, sir.
Now further, based on the kilowatt information, I would like to ask this question. Based on the kilowatt discussion, find the energy in kilowatt consumed in 10 hour by 4 devices for 500 watt. Clear? And this is also the next question. This is also the next question. So I would like you to solve this question first. First, solve this question number 1, right? It's visible to everyone.
So the first question.
Which one?
This one. A cooker has power rating. A cooker has power rating. This one is visible. My screen is visible to
Yes.
you.
Yes, sir.
Yes, sir.
The cooker has a power rating of 3 kilowatt. If a unit of electricity costs 20 paisa, it's very cheap. How much does it cost to run the appliance for 3 hours?
The P means in here P means power, right?
Yes. Question is clear to you, Madiha? Faz,
Yes.
Faz, you are not responding now. Why you are Faz and
Sir.
Jesly? Yeah.
Yes, sir. Yeah.
Yeah, respond. Jaslyn, did you get the meaning of the question? Did you try? Right, first power is sorry, what happened? Power is 3 kilowatt. Then time we have 3 hours. The cost per unit equal to 20 paisa. This one, how much you did?
We're still doing.
Okay.
So it's 20 paisa, right?
Sorry,
It's 20
paisa.
paisa. Okay.
Yeah, are you Indian?
Yes, I'm Indian.
So if you are having difficulty, I giving you hints. We learned that energy supplied to the circuit in time t, E is equal to P into T, right? This much amount will be supplied to the circuit in time t. So we are giving P and T. So we will be calculating the energy. Once energy we calculated, so we will check the dimensionality of energy. So first do the first step, then I call you and tell you the next step. Did you solve this line?
Is E is equal to 9, right?
9. That's 9 is good, but this is kilowatt hour, right? Kilowatt
Yes.
hour is 1 unit. So this means that 9 unit. 9 unit of energy we are consuming. So again is saying if a unit of electricity costs 20 paisa, then how much it costs to run an appliance for 3 hours? Question is clear?
Yes, sir.
So now proceed for the next step. Madiha, Faz, Jasleen, don't
Yes,
sleep.
sir.
Don't sleep. What happened? If 1 unit cost 20 paisa, then 9 unit cost how much? Cost of 9 unit will be 9 into 20 paisa. Right. This will be 180 paisa.
180. Yes.
So convert into rupees. How many rupees and how many paisa it, it will become? Now you have to change into the paisa and rupiah. Jaslyn, you are in meeting? So it will be how much? Ridwan, how much rupiah it means? How much rupiah and how much paisa? I said that can you convert this 180 paisa into rupiah? How much paisa it is? And how much rupiah? 100 paisa means how much rupiah? 100 paisa means how much rupiah?
1 rupiah.
1 rupiah. Okay. So this is
So
180.
1.8.
1 rupiah.
1.8.
1 rupee plus 80 paisa. Madiha, Jaslyn,
Yes, sir.
Faz, this question, did you understand the question and its solution?
Yes, sir.
How is that your answer? How much you got the answer? I don't know whether you are trying or not. So if you are done with this question, write it down and now proceed for the next question. Okay.
Sir,
Yes,
which
sir.
is the next question?
Next question. Yeah. Here the $1 billion question on the screen. This is the question, $1 billion question, this and this. This and this.
Okay. Sir.
No problem. You join again, no problem. Did you get the answer?
Yes. Sir.
Yes, sir.
Yes, sir. Faz is not responding. Jaslyn has network issue. So this energy will be nothing but this is what, right? So
Yes, sir.
we know that it is in the
That-
definition of kilowatt hour.
WIT.
Kilowatt. So it is in only in the watt. So we have to change in kilowatt, right? So 500 watt is how much kilowatt? 1 kilowatt is like this, 30, but it contains only 20. So to make it the kilowatt, what we will do? 500. Will we multiply it by this? Okay, then it will be uh, uh,
Sir, divide.
that's now 1,000 by 1,000, right? 1,000 by 1,000. So this will be the kilo, and this will be take the rest part. So this will be become 0.5 kilo, right?
Yes, sir.
So this is nothing but 0.5 this one kilo. Right. So this will be nothing but uh, 10 into 0.5. This zero, all zero are not significant. So this will be nothing but 50 kilowatt, right? Clear? No, not 50, only 5. Clear?
Yes, sir.
Yes,
And
sir.
that's 4 machine is being used. So for one machine, we are using 50 kilowatt find the energy in for the one machine. Okay, this is for the one machine. For the four machine, your device, the four device, it will be equal to 4 into 5. That is equal to 20. And that that kilowatt hour is nothing but 1 unit of energy. Clear?
Yes.
Clear to everyone? Now this is the last question. 11.3. Hope you will enjoy this question. First of all, this quantity is in watt. So change it into kilowatt and 8 hours per day for the 30 days, right? So change into hour, how many hour it is being used? 8 hour per days. So it means in 30 days, 8 into 30. So 240 hours, right? 8 3 is 24, then 240 hours. Okay. This will be again 0.4 kilowatt and the cost is 3 rupiah per kilowatt hour. Question is okay?
Yes, sir.
You got the question, Jaslyn? Then try it. Give it a try. What happened? See, first of all, we be calculating the energy E. This is nothing but P into T. So P is nothing but 0.4 kilowatt. Time is 3 hour in one day. So it will be 16 hour in 2 day, 24 hour in 3 day. So in 30 day, it will be 240 hour, 240 hour. Okay. So this will be the first step. Now you have to multiply it with 3 rupees. Okay, then next step, you just multiply it by 3. Whatever the answer you get, you just multiply it by 3. Thus, rate or consumption or cost. Cost will be this into 3, right? Got the point? Jocelyn got the point. Madiha, you got the point? Jocelyn, I'm not getting, as your mic is mute. So I'm not getting your sound. Jocelyn, yeah. So if you got this, that's it. Clear?
Yes, sir.
This is, so you understand the all concepts covered today? Any doubt on this topic? No, no doubts. Everything is fine. Is E. E is energy. We already said na how much energy we have transferred to the system in the given time t. So it is power into time. So it is equivalent to energy, or it is also equivalent to H. Okay, the heat transfer. So interchangeably you can use. We are reading about the learning about the energy consumption in the given time interval, right? So it is in kilowatt per hour. So if you got the answer, then okay. If you didn't get the answer, then try to find out the problems, diagnose it, and then solve it again. Okay. So I'm ending the class over here.